Okay, good evening, everyone. My name is Ahmad Shobirin and I'm going to present for my final year project about automated sorting machines. By the way, I'm from Bachelor of Mechanical Engineering departments in Segi College, Penang. So in this chapter, in this slide, I will share with you about the three main topics. There is problem statements, objective, methodology, and another one is the recommendation about this project. So for the problem statements, so what we have in our plan. So the thing is about this machine first. So this is machines that I created for eliminate all the manual process inside the plant, inside the factory. So the problem statement that we have is the time taken for manual sorting process. So usually the operator we have around 2 to 3% in one line to sort all the bag items or the bag fruits inside the production floor. So they talk a lot, so they waste time on that things. Especially for the night time, they probably have a nap or take a break 5 minutes sometime to take a nap. So there also the time taken to do all the manual process. So the second thing is the manual sorting is not accurate. This is because, especially for the night shift, they're probably really tired on the night, so they miss something that very bad that's supposed to be not inside the box to go to the customer. So we have to prevent it. So the last thing is the costing. So the costing is very important for the factory to run out the business. So if we can eliminate all these three, there should be no problem for us. So about the project objectives. So for the first one, we plan to increase the productivity of the factory by creating automated sorting machines. And instead of using operator, we use sensors with different colors to detect the different colors. So we can save a lot of cost over there. And the third one is to reduce cost, especially to reduce cost because we don't want to lose a lot of money. So by replace the machines with humans, I mean replace the human with the machine, so the ROI if become shorter. So let's go for the methodology. So in methodology, we will cover about 3 parts. The first one is a design programming, and the second one is the block diagram, and the third one is a project prototype. So for the program designing, so the first one we see the start, we put the starts, and then all the complex colors of the objects is on the conveyor, and then we have our color sensor and the photodiode to check the color, and if the color is green, it flat by 0 degrees and drop to the bucket. If the color is blue, the flapper turning 0 degrees to 90 degrees and drop into the bucket. And if the color is red, the flapper turning from 0 degree to 180 degrees, and then it's dropped to the bucket. And all this thing will end after it's dropped to the bucket. So the next one is the block diagram. So this IR sensor, we have 2 sensors over here, IR and the TSC 3200 color sensor. So IR sensor is just to detect the absence of the object. So for example, this OR object, so it just detect the objects, and the TCS color sensor is to detect the color, and then it's going to the processors, and then it's going to CPU, and the CPU will give the instructions to the servo motor to flip which board is supposed to be. So the next one is a project prototype. So we will cover about four chapter inside this one. The first one is a structure development. So over here we use just a wooden piece of wood. So it's around 40 inch, I think. No, 12 inch. Yeah, 12 inch. 12 inch of the wooden blocks. So the belt we're using as a fabric, as a belt, and then we have under the fabric is a PVC pipes at F a roller to move the fabrics forwards. And we have a 12-volt DC motor, and this is a detection sensor to detect the presence of the blocks or the blocks. And this is the color sensor that we have here. So over here we have our flipper or flipper that turn from 0 to 90 or from 0 to 180 degrees C. Yeah, 100 degree. Yeah, sorry. So the next one, this color sensor testing. So I just put the red color, the blocks inside the TC, inside the TC color sensor. So I want to show you guys that the sensor detect the red color. You see, the red color object is detected. The value is one is red, and then they also another data shows that the red color is detected. Same with the others. So this is the light blue, and then it shows it's a blue object is detected, and the rest. Yeah, for the next one is the infrared sensor. I want to show you the infrared sensor works is trigger the obstacle in front of it. So for now, he just trigger the code name is 1010. So present or not present, just like that. And then for the next round, they go to the for the color sensor. Sorry. So this is servo motor that we are using. So we're using a DF9 GMS servo motor. So the servo motor will rotate all the plates or the flipper. So if 0 degree is maintained with a blue box, is 90 degrees is the green box, and another 180 is for the red box. So I cannot show you the real prototype because I'm currently at the United States and I cannot bring my any project over here. I'm sorry for that. So the last one is the recommendations. So about this project is to make the sorting process more effective. So we may employ the various of sensor, including additional information like a weight, height. So we can sort a lot of things with a different shape and different height and weight. So the second one is a DC motor operating maintenance cost rise. So we using a stepper motor to increase the effectiveness. And the third one, developing a complete automated counter so we can track how many object actually has been sorted. So the fourth one is the object may also be sorted more accurately based on the color absorbment using the high precision and accuracy sensors. So the last one is the quality sensor may be utilized for sorting, and they don't require as much as maintenance and replacement. So that's all for me. Thank you for your time.